Inside a human kidney, millions of microscopic structures operate as a relentless filtration plant. Every day, this biological network processes nearly 180 liters of blood, enough volume to fill a large bathtub. These structures execute two precise tasks simultaneously. They strip out metabolic toxins while maintaining the exact fluid levels required for your body to function. Unlike the heart or the digestive tract, the kidneys are not wired with the specific pain receptors that trigger distress signals during localized tissue damage. Because this organ cannot send a pain response to the brain, its structural failure remains entirely unfelt. This diagram illustrates a biological anomaly. Internal function can drop from 100% down to 10%, while the organ remains physically intact on the surface. Millions of people are currently in active organ failure while believing they are healthy simply because they feel no physical change. This creates a diagnostic gap. Doctors cannot rely on patient discomfort to track dying tissue because the body's internal alarm system never sounds. Surviving this condition requires looking past how we feel and searching instead for hidden biological evidence. Microscopically, kidneys rely on a fragile web of blood vessels for filtration. Excessive salt spikes blood pressure, exerting intense mechanical force that eventually blows out these delicate vessels. High blood sugar acts as a chemical abrasive, degrading and scarring the remaining walls until they fail. Frequent use of NSAID painkillers like ibuprofen acts as a chemical tourniquet, restricting the blood flow necessary to keep surviving tissue alive. While hydration is important, drinking massive amounts of water cannot mechanically repair or flush out these scarred and blown vessels. These modern habits inflict a daily assault on an organ that is unable to repair its own internal architecture once it is damaged. As microscopic filters break down, the body produces subtle systemic anomalies instead of localized pain. When the filtration barrier fails, essential bodily proteins leak into the waste stream. This leakage is what creates the appearance of foamy urine. When fluid regulation fails, trapped water pools in the extremities, leading to visible swelling in the ankles, feet, and face. As heavy toxic waste builds up in the bloodstream, it creates a crushing state of persistent, unexplainable fatigue. Because these signs mimic common stress or aging, people often dismiss them until damage is advanced. To bypass the organ's silence, doctors test the blood for a specific performance metric known as GFR. GFR, or glomerular filtration rate, calculates the kidney's remaining filtration capacity. A score below 60 typically indicates the presence of chronic kidney disease. As the GFR score drops, muscle waste products like creatinine begin to accumulate in the blood, providing the primary evidence of filtration failure. These numbers allow us to visualize internal destruction while a patient still feels physically healthy. Chronic kidney disease progresses unidirectionally across 5 clinical stages. Stages 4 and 5 represent the threshold where structural damage is absolute and medical dialysis becomes necessary to sustain life. In stages 1 and 2, however, interventions like plant-focused diets and strict blood pressure control can halt further decay. These modifications are only effective if they are implemented while the kidney tissue is still viable. This makes it necessary to proactively request a kidney function blood test from a physician rather than waiting for symptoms to appear. To survive an organ failure that makes no sound, you must find the biological evidence before the damage becomes irreversible.